Okay, so here's problem 10 from the Net Proofs tutorial, and we are given A implies the quantity B or C, and B implies D, are two givens, and then we're trying to prove A implies the quantity C or D. So the first step when we're trying a direct proof is to look for a pattern in the proof statement and see if we can match that pattern somewhere in the givens. So I want you to look for a pattern and write down what it is that you've found on your paper briefly. And figure out which line it's on. So circle the number of the line that it's on. Then check with your neighbor and see if they found the same thing. Okay, so when we were looking at this, we wanted to get rid of the B or C and somehow get C or D, but I'm not focused on that right now. What I'm focused on is getting rid of B or C in this implication because it doesn't match what's on the right-hand side of my proof statement. So I'm looking at line 2, and I have B implies D, and so I have two implications here. I'm going to have to combine them. The only rule that lets me combine two implications and gets rid of stuff is hypothetical syllogism. So what I have to have, though, for hypothetical syllogism is I have to have the right-hand side of one implication matches the left-hand side of another one. So I need to get B or C implies something else, and I don't care what it is. So I look at line 2 and I say, well, I could OR C on the left, and if I do that, I have to OR C on the right, correct? So I can do that, and that's one of the implication rules, and it came from line 2. And then I could do hypothetical syllogism with lines 1 and 3. And am I done yet? Not quite. So it doesn't look exactly like what I'm trying to prove. So in order to get it to look exactly right, I have to do commutative. So from line 4, I did commutative. So in case you didn't notice, what I'm writing here is reference numbers to the lines that I'm using. So that's the source for something new that I'm deriving, and that's what I'm writing over here. So don't substitute stuff just because they have implications. You're not allowed to do it. There's not a rule called substitution. There is, but it only works if I have this. If I have a biconditional, I can do substitution. But otherwise, that's the only way to do it is to use hypothetical syllogism or modus ponens. Okay, so we can do this by contradiction also. So I want you to try that on your paper by contradiction. So remember the cheap way of doing by contradiction, right? If I already have a direct proof, the cheap way is what? Write the negation of the conclusion. So put a not, put a parentheses, copy this proof statement, and write as the reason negation of conclusion. Then I and these two things together because they're opposites. And that was on line 5 and line 6, and I did conjunction because everything in a proof is technically ANDed together, so I can AND them together on a line if I want to, and that is a contradiction. Did someone say really? It's a contradiction because we have a thing and we have its opposite. Both claim to be true. Because everything I write in a proof is a claim that it's true. So since both of them are claimed to be true and they're opposites, that can't happen at the same time in logic. Might happen in the world, but it's not happening in logic. Okay, so they can't happen at the same time, so the negation of the conclusion must be false. So it's a contradiction. I can't have a contradiction in logic, so something must have been wrong, and that's the negation of the conclusion, therefore the conclusion is true. So that was the cheap way to do a proof by contradiction. Now, the standard way is to do that negation of the conclusion right away. So write not parentheses. A implies C or D. I'm not skipping any step in doing this, because if you write down the negation of the conclusion wrong, you will be messed up. So don't skip anything. Just put not parentheses and copy down what you're trying to prove. This is the only time you get to negate something in your proof, is if you're going to do a proof by contradiction. Now I want to do De Morgan's with this, but De Morgan's doesn't work on implications. So we need to change the implication into an or, right? Okay, so try that on your paper. I want you to break it down as much as possible. That means distribute the nots from outside in. Use the implication rule, then use simplification if you can. And then we'll see what you get. Of your solutions, and the first thing that everybody did, which is good, was turned this implication into an or, because we don't have De Morgan's to spread a knot across parentheses. So that was from line 3 and the implication rule. And then 5, we're going to do De Morgan's, so we get not A, or not the quantity C or D. And that was 4 and De Morgan's. That's right, it's an and, not an or, because De Morgan's flips my operators. And then if I do double negation, I get A and not the quantity C or D. So that's 5 and double negation. And then if I'm going to distribute the second not, I get A and not C and not D. And that's from 6 and De Morgan's again. And then I can do simplification. So from 7, technically, if I was doing this in deep thought, it would probably make me keep some parentheses around this, and I'd have to simplify not C and not D, and then simplify the not C, and simplify the not D from that. But humans can look at stuff and skip steps. So I'm human. I can look at your things. I might act like a computer sometimes, but I'm not. Okay. Now, remember that when we did our proof by contradiction, that we can only get our contradiction by things that were derived from the negation of the conclusion. So all of these are, but mostly I'm going to use 8, 9, and 10, right? Because I wanted to simplify all this stuff so I didn't have to look at a complex long statement. So I really don't need 3 through 7 anymore. I'm going to use 8, 9, and 10 and combine them with the givens, which are lines 1 and 2, to see what I can get. Now, one thing you have to look out for is you cannot combine 9 and 1 together. So at least one person, I looked at their stuff, and they had A implies B as one of the lines of their proof. That is logically true, but none of our rules actually give it to us. So we are not allowed to do that. Okay, you can't do it directly. There's 2 different ways to do it, but I actually recommend that all you do is combine lines 1 and 8. And if I combine 1 and 8, what can I get? B or C. And don't put parentheses around stuff. So the minimum amount of parentheses is what you want to do. So less writing is good for you. So that was from modus ponens. And we've used this one. And we've used line 1. So now let's use 10 and 2. What will we get if we combine 10 and 2? We can get not B directly. Now, I saw some people who actually went through several steps to do this. So what they did is they converted B implies D to not B or D, and then they did disjunctive syllogism. And some people actually wrote that down, and then they wrote down this with conjunction. Don't do that. It's extra work, and I'm not sure what your tutor systems will do with that. So it's legal, but it's a pain. Also, Novanet only will display 19 lines, so you should try to keep your proofs that long. It'll store 22, but it will only show 19 of them. So you don't want things to disappear. So try to keep them shorter than that. So that's another reason to work them on paper. Make sure they're under 19 lines. 19 or under. You can do them all in that amount of time. Guaranteed. As long as you don't do this. Okay, so when we combined not D with B implies D, that was modus tollens. That was the if I'm not wet, it must not have rained rule. So that was 2 and 10 and modus tollens. Okay, by the way, if you're doing a proof on the test and you don't put reasons, it's going to be -2 for every reason that isn't there. So put your reasons. Okay, so we got not B, and we also have, so we've already used 1, 2, 8, and 10. So we should use, all of these are good now, but now we can combine any of these. So not C and B or C will give me P. So that's 9 and 11 and disjunctive syllogism. And we have not B and B from 12 and 13 and conjunction. And then that is a contradiction. And some of you may have actually gotten, instead actually done 11 and 12 and gotten C and then C and not C as your contradiction. So any of those is fine. If you get anything ANDed with its opposite, you're done with the proof. Yes, NovaNet is sufficiently intelligent that it will accept any contradiction that you get. So anything you derive is going to be fine. It's just it doesn't store more than 19 lines. And actually, I made a mistake. The rule for B implies D, we ORed a C on both sides. That's actually not on your printed axiom list. So let me give you a workaround for that. I apologize for using a rule that doesn't exist. It existed on an old version. It is not okay to skip 8, 9, and 10. So that was the question. Can we skip 8, 9, and 10? No, you cannot. You could, but if you did, what you'd have to do is the new things I derive, I have to put them in that AND statement. And I don't think that the NovaNet tutorial will let you do it anyway. So it's technically okay, but then I would have to, when I derive B or C, I'd have to put B or C and not C and not D, because I have to actually use the whole line that I'm using. So when I combine lines, I'm actually combining whole lines usually. I have to, because I'm not allowed to use them I'm not allowed to use the rules any other way. That's why I have to do simplification. That's a good question.